Alright, today we're going to work on assigning oxidation numbers. Assigning oxidation numbers will help us to determine what kind of reaction we have. In the world, we really only have two types of reactions, two overall types of reactions. Redox reactions and acid and base reactions. So what I'm going to do today is I'm going to give you a brief tutorial on how to assign oxidation numbers. Assigning oxidation numbers will help us to determine if something's a redox reaction or not. So in order to assign oxidation numbers, we have a few rules. Okay, right here we have a few rules. 1, 2, 3, 4, 5, 6 rules. All right. An element in an uncombined state is 0. All right. So while I'm going over these rules, I'm going to kind of show you what's happening down here in this practice section. The top part of this are your questions, and the answers are down at the bottom. Okay, so the first rule says that an element in its uncombined state is 0. Well, the only element that we have in an uncombined state here would be nitrogen. Now, normally an uncombined state means that they're just going to be by themselves. Since nitrogen is a diatomic molecule, that's what it is in its uncombined state. It's going to be N2. So its oxidation state is going to be 0. Okay? The second rule says that a monatomic ion equals the charge on the ion. Well, monatomic means one atom, okay? So we have that in barium. Barium's charge is 2+. So its oxidation number is going to be +2. Now, assigning oxidation numbers is very similar to assigning the charges, okay? Very similar. Alright, rule number 3 says that hydrogen is generally +1. In hydrides, it's -1. So if it's bonding to a non-metal, it's +1. A metal, it's -1. Okay, so let's look at number 3. That number 3 is an example of that. Hi. Well, hydrogen is bonded to a non-metal, so since it's bonded to a non-metal, the oxidation state of hydrogen is +1. So our answer would be +1. Rule number 4 says oxygen is generally -2. In peroxides, it's -1. Alright, well, you should remember that the polyatomic ion peroxide is O2 -2. So, each oxygen is going to have an oxidation state of -1. Number 5. Elements other than oxygen and hydrogen in a neutral atom in such that the sum of the oxidation for all atoms in the compound is 0. So, number 5. If it's not charged, it's 0. Okay? Elements other than oxygen and hydrogen in a polyatomic ion is such that the sum of the oxidation numbers for all atoms in the ion equals the charge of the ion. Okay, so we're going to have to look at ion charge. For example, bromine. Bromine is in group 17. Group 17 has a -1 charge. So the bromine is -1. Now remember, we're trying to find the underlined species. Alright, let's look at the next one. Chlorine each has a charge of -1. We have 2 of them, so the copper's oxidation state must be +2. Let's look at the HNO3. Okay, and I'm going to put this one as an example. HNO3. We can set these up as sort of an algebra problem. Okay, so the oxidation state of the hydrogen plus the oxidation state of the nitrogen plus the oxidation state of 3 times that of oxygen equals whatever your charge up here is. Okay, now this is a neutral atom, so the charge will be equal to 0. If it were -1, it would be equal to -1. Now let's see if we can assign some charges to this. Well, hydrogen is attached to a polyatomic ion. If polyatomic ions are just like metals, so hydrogen is going to have a +1 oxidation state. Nitrogen is what we're looking for, so we'll just use N as our variable. We have 3 oxygen. Oxygen's oxidation state is generally -2, except for when it's a peroxide, and it's not acting as a peroxide here. So we have -2. How do we know it's not acting as a peroxide? Because it needs to be O2 2-. Okay, is equal to 0. So we can now just solve this algebra problem and solve for N. Okay, so N is equal to 5, so nitrogen's oxidation state would be plus 5. So hopefully that gives you a little bit of an overview of how to assign oxidation numbers.